All right, this video we're going to talk about common logs. Common log is the log that has a base 10. Okay, it's called that because it is the most commonly used log, and it's usually written with no base at all. Okay, so i.e. log of 2x, that would be assumed to have a base of 10. All right, but it's rarely written with the base 10 written in there. Because it is so common, that kind of got phased out over time. Now, the common log is actually sort of obsolete at this point. The reason that we used to learn a whole lot about them is because it allowed us to put all these logs into our calculator. Okay, but now we can really put any base log in the calculator. So it's a little obsolete, but there are some useful things that you can do with common logs that that still pertain to our class, even though we do have these calculators that are a little more powerful these days. So if I gave you log base 4 of 9 and just told you to evaluate it, what does that equal? Okay, it's not going to be a whole number because there's no whole number that 4 to the power of that equals 9. Okay, but these days we just type this in our calculator. All right, so we press our second 10 to the x button, and then it allows you to type in 4 for the base right here, and then we type in 9 inside the parentheses, and we get 1.58 approximately. All right, well, I want to show you back in the olden days, back with these calculators. Okay, there is no log base button. Okay, that's not exactly true, but the log button right on the front of the calculator, right here, you see it, log, click that. See how it doesn't tell you a place to put the base. It doesn't allow you to put that in there. Now, eventually they updated this enough to where they did include that, but you have to go searching through a few menus to get to it. All right, so the way that people evaluated the logs back with these calculators, especially before the newest update, is they use the change of base formula. So we learned about the change of base formula. I can change this log to be any base that I want. So let's say I want it to be base 10, the common log. So I do log base 10 of 9, that's the argument, that's this part. And then I divide that by log base 10 of the original base, 4. Okay, in other words, if I don't write the base 10s, just use the common log, that's log 9 divided by log 4. And that allowed you to take this calculator that only had this common log button and do log 9 and divide that by log 4. And you'd be able to get the answer that way. There's our 1.58 that it was equal to. All right, so just keep that change of base formula in mind. It does come in useful in other situations as well. And I just wanted you to see kind of why common logs were originally learned the first time around. All right, now let's go over some stuff that we can use them for today. All right, so back to exponential equations. So this is from 7-1. Okay, this is on quiz 4 that y'all took a couple weeks ago. So what I did not include on that quiz and in that section were problems like this. So remember the way that we used to solve this is we do 2 to the 3x, and then we'd have to transform this 15 into like 2 to the 4th or 2 to the something. Okay, the problem is 15 does not transform into 2 to the anything. It's not a power of 2. Okay, in fact, if I try to break it down, I'm not going to get any 2's at all. I'm going to get a 3 and a 5. Okay, so how do we solve this problem when I can't transform the base into a 2? We use a log. Log is the opposite of an exponential, so that's how we cancel it out. So what we're going to do is we're going to take the log of both sides, all right, and I'm just going to use the common log. Log of 2 to the 3x equals log of 15. All right, now remember the rules about exponents. You're allowed to bring those to the front when it's in a log like this. So that's going to be 3x log of 2 equals log of 15. Okay, well, to get x by itself, I just need to divide by what's not x. That's 3 and log of 2, and divided by 3 log of 2. All right, so the 3's cancel and the logs cancel. And then I have log 15 divided by 3 log 2. So x approximately equals whatever that is. All right, when you're using our new calculators, if you're doing common log, you actually don't even have to type in the base. It allows you to, but if you just don't type anything there, Oh, don't know what happened there. All right, so if we just type in log of 15, and then we divide that by 3 log of, what was it, 2, and hit enter, it automatically puts in the tens in there for you. All right, now you can type in the tens. It's like doesn't really save you any more time to not type them in, but just let you know that it automatically puts the tens in there if you don't type anything. So 1.3023. All right, so on this next one, I'm going to show you a little bit different way to go about this that uses the power of our new calculators a little bit better. So on the last problem, we common logged both sides, and then we just used our properties and divided it out. So another thing you can do is cancel this 4 out. So we're still going to take the log of both sides, but I'm going to take a specific log. To cancel out a 4, I need to do a log with a base of 4. Log base 4 and base 4 will cancel each other out. And then I can do that over here as well. Take the log base 4. Alright, so that'll cancel this out, leaving me with x minus 1. And this is equal to log base 4 of 5. Then all I have to do is add 1. And I get x is approximately equal. Okay, remember, you're not going to be able to add these together. This is inside the log. The 1 is not. So you just need to add these together separately. So we do log base 4 of 5. Make sure you arrow out of the parentheses, plus 1. And you get 2.161. All right, now just so you can see that they are the same thing, let's do this the way I showed you on the last problem. So what if I just took the common log of 4 to the x minus 1 and common log of 5? Okay, well, we take the x minus 1 and move it to the front. Okay, then we would divide by log of 4. All right, we have x minus 1 equals log 5 over log 4. And then we'd add 1. Okay, then we can type this into the calculator and see what we get. Now I want to bring your attention to something. Over here it was log base 4 of 5 plus 1. Here it's log 5 over log 4 plus 1. Okay, remember what we did on the first page. The change of base formula. Log base 4 of 9 became log of 9 over 4, over log of 4. That's the same exact thing that's happening here. Log base 4 of 5 is become log of 5 over log of 4. So it's going to give us the same answer either way that we do it. It's up to you which way you think is better or easier to you. Doesn't really matter. As long as you got your steps right, you're going to be good to go. So let's just type this in, make sure we're getting the same thing here. So log of 5 divided by log of 4 plus 1. All right, make sure when it corrects itself on its notation that it looks the same as you wrote on your paper. It does. You see that we get the same decimal approximation either way that we do it. So we're good to go there, 2.161.